Good morning, everyone. Okay, inform your friends to join this class. So we will start the
Good
session
morning.
for 2 minutes. Good morning. Okay, good morning, guys. So we have started our 15. So in last class we have seen the matrix of graph, and now we will look at about the relationship. So we will look at about the relationship about what is the relationship and what is of matrix. So So before going to that, and in previously we have seen about the matrix of graph, right? So now you have seen about the how we are representing in the matrix format to a flow graph. So same this how we are showing the relationship and how the transaction is performing in the nodes. So same thing. Now we will look at about the relationship and what is actually a relationship. Relationship is nothing but is a part of property that connected to the any two nodes. If A and B are any things connecting by the relation, that so it will be a set has the relationship or a R to B. Okay, so if you are having the two nodes, for example, you have the node A and the B, and the A is traveling to the B node, and that line is represented by the R. Okay, so that is the relation of that line is a connection between the two nodes that is representing as a R. So that is a relation of that node. So it will be symbolic representation. So that will be represented in the form of ARB. So it will be represented as a ARB. So for example, here may look at my cursor. So this is A node and this is B node. So here and this node is traveling. So this relationship will be represented as a R. So that is called as a ARB, where R is, so we will write as a R over there. So like this you are going to represent that node ARB. Okay, this is it is shows the connection between the two nodes, that is A and B nodes. Okay, so they, if you are having the more than two nodes, it will be show in that nodes. Okay, so it will, by seeing the graph you can say the node representation. Okay, so okay, graph is consist of separate set of attributes of objects called the nodes and the relationship between the nodes. So ARB, which is set that has been the relationship and it is denoted by the links as A to B. So say the node, the relationship of the node, it will be a denoted. Okay, so R is denoted as like that. So we are represent, we will write in the form of as a ARB. So this ARB is saying that A is having the relation between the B node and there is that node will be representing a by the R symbol. Okay, so we have the properties of relationship. We have the four types of relationship: transaction, reflection, system, symmetric and anti-symmetric matrix. So and this is the relationship we have in this. So transactive matrix is nothing but there is a existing two relationship ARB and BRB, and the relation R is said to be have the transaction property. Okay, if ARB, okay, and BRC equals to ARC. Okay, for example, if A is equals to B and B equals to C, and then A is equals to C, if A is greater than B, okay, B is greater than C. So this is the look at this in this node. The transaction is ARB and the BRC. A implementing ARC. So in this matrix, what it will be called transaction? Nothing but a two relationship. ARB and the BRC are the relation of R is said to be a transaction property. So if you're having the, if A is equals to B and B equals to C, then A is equals to C. So if A is greater than B and the B is greater than the C, and then C A is greater than C. So that time, 1 second guys. So in this relationship, so it will be a example of the connection. It will be if you are having the connection between greater than, less than, equals to, or less than, equals to, or faster than, slower than, take more time than. So these types of relationship will be shown in this graph as a transaction relationship, and we are represented as a ARB and BRC or ARC. This is the way we are going to represent in this relationship. So next we have the reflection relationship. In this, if there are two existing nodes, okay, if they if there is existing two relationship between the nodes A and A, that is ARA, okay, then R is said to be a reflection relationship. Okay, so in this we look at here, it will be a reflection if you are having the same, not like A and B. Okay, so that time we are representing as a so A equals to A, okay, reflection, or A is not equals to A, is reflection. We are representing in this form of, in this reflection. If it, okay guys, so if you're having A equals to A, for example, you have two nodes A, and A is traveling, and A is carrying, A is reflecting to you. So that time what you are doing means you are writing as a AR A. Okay, so this is the way you will represent as a AR relationship. It will call the reflective relationship, or A equals to A, or A is not equals to A. That time you will represent these types of things. Okay, so for example, okay, so look at here. So you have ARR. So this time you are going to reflect this relationship as a ARR. Okay, so if you are having a self node A, okay, then it is coming to be here from B node to A. So that time you are representing A equals to A is not equals to A. That time you are this, if the situation is like that, you are representing this way. You are showing the relationship in this form. So next we have the systematic relationship. A relation R, if A relation R is said to be a systematic if A R B or A B R A. So systematic relationship, that if there is a link or a connection between the two nodes, okay, that is if A to B, then there should also be a link from B to A. So it is in the form of parallel. If you are having the two, one notice A is traveling to the B and B should be a travel to the A, so that time it is called the systematic relationship. Okay, so the links or connection between the two nodes, that is from A to B, then it should be also a linked from B to A. So this is the way that is called the systematic relationship. And the relationship which is not systematic will be represented a direct graph. Okay, the indirect graph is nothing but a systematic relationship. Okay, for example, if A is equals to B, then B is equals to A. This is the systematic relationship. If a non-systematic relationship is nothing but A is greater than B, then B is greater than A. So this is a non-systematic relationship. If we are having A is equals to B and B is equals to A, so then it is called the systematic relationship. If it is not having the if it is having A greater than B or then B greater than A, that time is not a non-systematic graph relationship. Is nothing but a direct graph. So for example, you have two nodes A and B. So A is traveling the node of A R to B to A, and B is traveling to R B to A to B. So this is called the symmetric relation. So next we have the anti-symmetric relation. So that relation we are representing is in the form of ARB or BRA. So next we have the anti-symmetric relationship. If relationship ARB and BRA, that's A is equals to B, then R is said to be a anti-symmetric relationship. Okay, if for example, if A is equals to B and B is equals to A, then A is equals to B, right? So if A greater than B and the B greater than A, then A is equals to B. So when if the relationship in the previous A are B and the B are A, that is A is equals to B. Okay, then R is said to be a anti-symmetric relation. Okay. So next we have the equivalence relationship. In this relationship, the relationship will satisfy the three properties, that is reflection, symmetry, and mm, trans- transitive. Then it is called the equivalence relationship. So if the three properties it will be there in the relationship, it will call the equivalence relationship. So in this so these three properties should be there in that. So then it is called that equivalence relationship. So in this, it should be having the like ARB, ARB and BRC. So this kind of or ARA. So ARB and BRR. So A is equals to B and B is equals to A, or A is greater than B and B is greater than C, or A is equals to B. This if these things are possible, then it is called the equivalence relationship. Transitive are known as equivalence relationship. So next we have the partial ordering relationship. The relationship which satisfies the three property, that is reflection and transaction and anti-symmetric. So if three properties are there, then it is called the partial ordering relationship. So this is the four types of relationships are there. The so that is anti anti-symmetric and symmetric matrix, and next we have the transactive and and reflective. So these four are the important relationship. So if you this four relationship, you have to write in the example in the exam. And next we have the power of matrix. So power is matrix is nothing but each entry in the graph matrix express the relationship between the pairs of nodes that corresponding to the that entry. So each and every matrix there will be a relationship between the nodes. So it will be showing the relationship among and the pairs of nodes. So it is displaying, it is the power of a matrix and the squaring of matrix, a new matrix that express the relation between the each pairs of nodes, one international load under the nodes under the assumption that the relation is transactive. The relation, the square of a matrix represent the all path segments two link long. So the three power representation represent the all path segments that three links long. So if we have the three nodes, if you are having the three nodes, then time you are using with the 3 power of matrix, okay, 3 into 3 matrix. If you have the two true nodes, then you are going with the 2 into 2 matrix. So this is the way you are representing, and in the matrix we are showing the relationship about the graph, how the flow graph is traveling from the one node to and the another node, and what is the weightage of that nodes, and the corrections and the relations about the nodes we are represent in the matrix format. And this is the way you are represent, this is the power of your matrix. By seeing the flow graph, you are representing in the graphical form, in the matrix format. Okay, so in this matrix we are showing the relationship and the connections and the weightage of your matrix. So next we have the matrix power and the property. Giving the matrix whose entering A and J, the square of that matrix is A often. So we have the formula A and J is equals to sigma power n k is equals to 1 A I k and A I j. Is nothing but if you are having the matrix A power 2. So if you are having the matrix of A power 2, for example you have matrix of 1 2 3 4 and 1 2 3 4. So same, you have matrix of A, and if you are having the power 2, then you are going with A. That time you are writing that matrix as a 2 time. For example, you have matrix of 1 2 3 4. Okay, 2 by 2 matrix 1 2 3 4. So this time we are going to A power 2 matrix it is. So you are going to calculate that matrix, right? So that time you are writing A is nothing but a row and the J is nothing but a column. So you are writing the A I J is equals to sigma A I K and A I J. So here we are writing as a 1 plus 1, okay, plus 2 plus 2. So this is the way you are representing this matrix, guys. So more generally given the two matrix, okay, A and B which increase the A I K and B I J representation, the properties into the new matrix C, where the entries are C I J, where we are writing the C I J sigma A I K B K J. K is equals to 1 and n power 3. So if you are having the two matrix A and B, that time what you are doing, A into B, A matrix will be multiplied by the B matrix. So we will get the C value from them. So we are taking, for example, for A matrix we have the input 1 2 3 4, and the B matrix 1 we have the 1 3 1 6 4 5. So that time what you are writing, so we are multiplying that matrix as a 1 into 1 plus 2 into 1. This way you are multiplying over there. And the in place of k, how you are writing, k is equals to 1 we have. So you are writing a 1 by 1, b 1 into 1. Okay, this is the way you are representing the k value. So you will get the result, whatever the result you will get from the sigma A and K and B Kj. So that will be returning in this way, in this form, Cij. Next we have the power of matrix, product of matrix. Product of matrix, if they are two matrix with different entry. So in this So next we have the product of matrix. If there are two more with difference entry, for example xij and the kij, then the product of this matrix will be a zij sigma power n k is equals to 1 z xi k plus yij. The product of matrix x and y is equals to z. So when if x and y will be x into y we will do, then we will get the z value. So look at this, guys. Right. So look at this thing. This is the power of matrix, and this is the formula. Okay, and that is the formula. What is the formula? We have that xij is equals to sigma power n k is equals to 1 zik plus into yij. So the product of matrix x and y is z. So we are multiplying the x and y and we are getting the z value. So look at here. So we are representing these things in the look at here. So row with the column. So z I x11 y11 plus x12 y21 x13 x13 and y31. So x14 and y41. So we are multiplying this. Okay, so this is the way you are getting the result of your x value. So we are obtaining x value is obtaining by the multiplying each row, okay, enter into the matrix x and the column in the matrix y and adding them, and we are getting the results of your x values. So this is your x value result. This is the way you will get the x value. So previously also I have said you this examples, guys, about the relationship and transaction. Just I will show this in this diagram. Okay, transaction and the relationship. So this is the way you are representing our matrix, a product of matrix, and this is the power of the matrix. And just now we have seen about the relationship, right? So in this relationship, I have said you the A R B. So this is the if A node and the B node having traveling this is R will be represented with this lines. Okay, this relation, this connection is called as the R. So this connection will be representing it as a R. Okay, if we are having the A is equals to A and A is equals to B, that time you are writing as A, that relationship we are representing as A R A. So in the most of the programs we will write this A is equals to B and B is equals to C, B is equals to A, like this, equals to R, A is equals to B and B is equals to A. So this is the way you will represent, right? So that time we are going to write in this way. Okay, so this will be write as A R B B R A. So we have the relation of this. So if A B node, okay, these two nodes, A will be traveling, this is the R node, A is traveling to B and B is traveling to R A. So this is the relationship among them. Then it will be called the equivalence anti-symmetric relationship. So you will get the if two nodes, the two graphs. So A is traveling to B and B is traveling to A. This is called the symmetric matrix. Okay. So this matrix will be represented in this form. Okay, when it is A is equals to B and B is equals to C and C is equals to A. So reflection is nothing but A. If you're having the if you're having like or operation like what I should say, equals to, less than, equals to, or greater than. Okay, this time will this types of relationship will be represented in the transaction relationship, and that will be written as a R B. Okay, a B R C, like that. This way you are representing the graph. So next we have the partitioning algorithm and the node reduction algorithm. So this algorithm we will see in the next class. And before that, guys, let me know, guys, about how many members are going to come to college from first. Hello, hello. Let me know, guys, from first. How many members are joining to the college? So, anyone say something? What happened, guys? Okay, guys, we have two topics left in the fifth unit. Okay, that is non-reduction algorithm. Okay, so we'll see in the next class. And next we will see about the lab. If you give me the if you are coming from first or not, if you said me, so I can go with the lab or not. I will prepare for that, guys. So let me know if you're coming for. Anyone Jason is in the class. Hello. Okay, no, please. Attendance. Attendance, please. Alright, it's audible or not? 16
Ma'am,
series.
18 series 501.
Give some response, guys. If I'm
18
asking to you,
series 501, ma'am.
how many times I should ask?
18 series 505, ma'am.
16 series.
16 series 5E2, ma'am.
Wait, 16. Next. Anyone is in 16 series?
17 series 5C7, ma'am.
5.
C7.
Next.
563, ma'am.
Next. 17 series. 17 series. Okay, 1 to 10.
501, ma'am.
Next.
505, ma'am.
Next.
508, ma'am.
Next. 10 to 20.
509, ma'am.
Okay, next.
509, ma'am.
Next.
513,
512, ma'am.
Okay, next.
513, ma'am.
Next. (11 to 20).
520, ma'am.
Next. 21 to 30.
522, ma'am.
Next.
523, ma'am.
Next.
528, ma'am.
Next. 30 to 40. 30 to 40.
539, ma'am. 541, ma'am.
41 to 50.
541.
Okay, next.
542, ma'am.
Next.
543, ma'am.
Next.
545, ma'am.
Next.
546, ma'am.
Next.
549, ma'am.
50 to 60.
Ma'am, 551.
5.
51, ma'am.
Okay, next.
557, ma'am.
Next. So I'm saying the present is number 57,
560,
okay. 60, 57, okay.
515, ma'am.
15. Anyone else? Anyone else? So, okay, present is number 60, 57, 51, 49, 48, 46, 45, 43, 42, 41, 40. That is, we have 12 experiments. You have to write the 12 experiment in report. And
ma'am,
I think
539 also present, ma'am.
5.
539, ma'am.
Okay. So guys, you have to write your observation and record. You have to just write your experiments, guys. That is from 1st to 12. You have 13 experiments. You have to write in that record. All 13 experiment. And from tomorrow, I will finish our syllabus. Okay. So from day after tomorrow, that's why I'm asking us, if you are guys coming to the college from the first, let me know. So if you are not coming, so I will continue our lab experiments, guys. I am waiting for it. I uploaded the attendance by 16. Okay, guys, you can leave now.